This lecture looks at numerical and graphical summaries for multiple sample studies. It is in Module 2, Comparing Groups. Let's look at the numerical and graphical summaries for study example 1. Remember that we are looking at the relationship between taking AP or college courses and the number of sleep hours for high school students. We can find the mean and standard deviation for each group just as we did in previous lectures. In this case, we will have 3 means and 3 standard deviations or variances, as there are 3 total groups. Using Excel, we find that the mean for those who took no AP or college courses is 7.01 hours. The mean for those who took one AP or college course is 6.82 hours, and the mean for those who took 2 or more AP or college courses is 6.73 hours. Notice that our last observation is in G 2048. Unfortunately, some who reported taking AP or college courses did not report how many AP or college courses they were taking. Though in practice we should find a way to deal with this missing data, for the purposes of this study, we will simply exclude these observations. How to deal with missing data should be covered in a more advanced statistics course. Again, we will have 3 standard deviations, 1 for each group. Our standard deviations for 0, 1, and 2 or more AP or college courses are 1.2458, 1.1233, and 1.0461, respectively. Graphically, we could make a histogram for each group. However, comparing 3 histograms, or more if we had more groups, can be difficult. Instead, we can use a mean plot to compare the means and standard deviations for the 3 groups. The x-axis has the group information, in this case the number of AP or college courses, while the y-axis scale is mean sleep hours. The height of the bar represents the mean for that particular group, while the standard deviation line represents the mean plus the standard deviation and the mean minus the standard deviation. For the purposes of this graph, the standard deviation is not uniform across the groups. It is calculated separately for each group. A mean plot allows us to compare centers and spreads for the groups. A box plot can show similarities or differences in center and spread. However, a box plot summarizes different information than the mean plot does. Using a box plot can be easier than comparing many histograms. A box plot is a graphical representation of the 5-number summary. The 5-number summary consists of the maximum, the third quartile, the median, the first quartile, and the minimum. To find the 5-number summary, the data must be ordered from smallest to largest. Excel does this automatically for you. The minimum is the smallest value in the dataset. The maximum is the largest value in the dataset. The median, or second quartile, is the middle value of the data. The first quartile is the midpoint of the minimum and the median, while the third quartile is the midpoint of the median and the maximum. Therefore, each section of the box plot contains 25% of the data. The minimum to the first quartile is 25%. The first quartile to the median is 25%. The median to the third quartile is 25%. And the third quartile to the maximum is 25%. The median is considered the measure of center. The measures of spread associated with the median are the range and the interquartile range. The range is the difference between the maximum and the minimum, while the interquartile range is the difference between the third and first quartiles. For example, let's say we have the numbers 17, 25, 2, 10, 11, 13, and 21. We can order these from smallest to largest and find the 5-number summary. Please pause this video while you try to find the 5-number summary on your own. The minimum is the smallest value in the dataset, which is 2. The maximum is the largest value in the dataset, which is 25. The median is the middle value of the dataset, which is 13. There are many ways to calculate quartiles. For large datasets, you will most likely get similar results for the different methods, but you may get very different results if you have a small dataset. Excel has 2 ways of calculating quartiles. inclusive, and exclusive. The inclusive method includes the median, if it is in the dataset, and the calculation of the quartiles, while the exclusive method does not include the median in the calculation of the quartiles. In this example, using the inclusive method, the first quartile would be 10.5, while the third quartile would be 19. Using the exclusive method, the first quartile would be 10, while the third quartile would be 21. For this class, whichever Excel function you use is fine, as long as you are consistent in your calculations. That is, if you use the exclusive function to find the first quartile, also use it to find the third quartile, and do the same for all the groups. Now we can look at creating confidence intervals in the context of study example 1. So actually, we will not do confidence intervals for multiple sample studies. When confidence intervals are made for more than 2 groups, they are used to estimate the mean for each group instead of for comparison. Therefore, the method for calculating a confidence interval is the same as outlined in the one sample studies lecture, except you would make 3 confidence intervals, 1 for each group. We will not do this in this course, so you do not need to worry about making confidence intervals in your concept practices. Let's discuss summaries and estimation for study example 2. In this example, we are looking at 3 groups: those who had a pet present during the mental task, those who had a human friend present during the mental task, and those who had no one present during the mental task. In Concept Practice 7, you will calculate the means and standard deviations for each of the 3 groups and create a mean plot that summarizes these means and standard deviations. In addition, you will have an extra credit option to create a box plot for the 3 groups, which is detailed in the Concept Practice 7 assignment area.